All right, let's dive right in. We're going to peel back the sleek, shiny surface of the gadgets you use every single day and take a look at the hidden world of engineering that's happening right under your fingertips. So have you ever wondered why your phone gets super hot? Or why your Bluetooth just cuts out for no reason? Yeah, we've all been there, right? You're on an important call and suddenly, static. Or you're deep into a game and your phone feels like it could cook an egg. Well, it turns out those aren't just random glitches. They're actually signs of an invisible war raging inside your tech. See, beneath that smooth glass and metal, it's a total battlefield. Every tiny component in your phone, your laptop, even your car, they're all constantly creating these invisible forces. We're talking about heat and what's called electronic noise. And if you just let them run wild, well, that's when you get glitches, slowdowns, and sometimes your device just gives up completely. So engineers are basically fighting this battle 24/7. Okay, so first up, let's talk about the first of these invisible enemies, electronic noise. And this is a huge deal because the smaller and more powerful our gadgets get, the crazier this problem becomes. The technical term for this is electromagnetic interference. You'll see it as EMI. And really, the easiest way to get your head around it is to think about old-school radio static. It's just unwanted energy from one part of your device that's bleeding over and messing with the signals of another part. It just creates total chaos inside. Think about it like this. All the little parts inside your phone are trying to have these super fast, super precise conversations with each other. But EMI is like a constant loud chatter happening in the same room. It just drowns everything out. And that chatter can mess with pretty much everything, from your Wi-Fi connection to the critical data being crunched by the main processor. So how in the world do you quiet all that chatter? Well, this is where it gets really cool. The solution is to use these specialized paper-thin sheets. They're kind of like the soundproofing foam you'd see in a recording studio, but they're built for electronics. What they do is they literally absorb all that unwanted electronic noise and convert it into a tiny, totally harmless amount of heat. And what's fascinating is that it's not a one-size-fits-all kind of deal. You see, different parts create noise at different frequencies. You've got the low rumbles coming from power supplies, the mid-range chatter from the processors, and then these really high-pitched squeals from things like your 5G antenna. So engineers have to use a very specific tool for each one, using different types of sheets to hunt down and cancel out those exact frequencies. And it's not just about absorbing the noise. The toolkit is actually pretty big. It also includes things like these conductive tapes to help ground any stray electricity, and even these foam gaskets that can totally seal off a sensitive area, basically building a little shield around it. It's a whole multi-layered defense system, all packed into that tiny device. All right, let's switch gears to the other big villain. And this is one you've definitely felt before: heat. I mean, anytime your laptop starts getting toasty on your lap, that's exactly what we're talking about. It's the natural byproduct of all that amazing high-speed processing. You know, it's a lot like a car engine. The chips in our gadgets have a sweet spot, an ideal temperature where they run best. If they get too hot, they actually have to slow themselves down to avoid damage. That's what thermal throttling is. But if they get way too hot, they can be fried for good. So you can see why managing heat is one of the single biggest headaches for engineers today. Okay, so the big question is, how do you get that heat away from the thing that's getting hot? You might think you can just stick a piece of metal, a heat sink, on top of the chip and problem solved. But not so fast. If you zoomed in with a microscope, you'd see that neither surface is perfectly flat. They're full of these teeny tiny air gaps. And here's the kicker. Air is a horrible conductor of heat. It's an insulator. So these thermal tapes, they act like a bridge. They fill in all those gaps and create a perfect little superhighway for the heat to escape. And yeah, just like we saw with the noise-fighting materials, there's no single answer here either. The solutions are super specialized. You've got these incredibly thin tapes for small parts, but then you also have these thicker, almost putty-like fillers that can mold themselves into weirdly shaped gaps. Basically, every little nook and cranny inside a device needs its own custom-fit solution. But moving heat from point A to point B, that's one thing. What happens when you're dealing with something as thin as a modern smartphone? There's just no room to put a big old heatsink in there. So what's the play? Well, this is where the material science gets really smart. And that brings us to a real game changer of a material, graphene. See, most materials are good at moving heat in one direction, like straight up and away from the source. But graphene is just unbelievably good at spreading that heat out sideways. And that one property, that's the secret sauce. It's what lets engineers design these impossibly thin phones and laptops that don't need big, clunky fans. I mean, this comparison says it all, right? With normal cooling, you get this intense, really damaging hotspot right on top of the processor. But a graphene sheet, it takes that same intense heat and just spreads it out super fast across its whole surface. It gets rid of the hotspot, and by doing that, it keeps the whole system cooler, more stable, and ultimately that's what lets them pack more power into a smaller, sleeker device. Okay, so we've looked at the battles against noise and heat. Now, let's just zoom out for a second and see why winning these invisible wars is so unbelievably important for all the tech that's coming next. The thing is, every single leap forward we make in technology, we're talking faster chips, more stable connections, devices that are thinner and lighter, all of it depends on these kinds of foundational materials. You just can't build the tech of the future if you haven't solved these basic physics problems first. And don't just think this is about your phone or your laptop. This kind of invisible engineering is absolutely everywhere. It's inside the computers that run electric cars. It's in the huge base stations that power our 5G networks. It's critical for the sensitive medical equipment in hospitals. It's in pretty much every smart device you can think of. When you get right down to it, all of this super complex science and engineering, it's all for a pretty simple reason. And I think this quote really sums it up perfectly. It's about making the tech that we all depend on just work better, more reliably, and feel completely seamless. So, hey, the next time you pick up your phone and it feels a little warm, or maybe you just notice your Bluetooth connection is rock solid, just take a second to think about that invisible battlefield humming away inside. Think about these incredible materials that are quietly winning that war for you. It really makes you wonder, right? As we keep pushing technology and the laws of physics, what's the next invisible force we're going to have to tame?